1.2a. Radian measure. Radian sounds like radius. So it has to deal with the radius of the circle. All right. In a circle, there are 360 degrees. The radius of the circle goes from the center to the edge. To find the area, or the circumference of the circle, circumference of the circle, it's 2 pi times the radians, right? 2 pi times the number of 2 pi times the radius. So, if the radius of a circle is 1 unit, okay, 1 unit, the circumference of the circle would be 2 pi times 1, or just 2 pi, correct? So, in a circle with a radius of 1, the circumference is 2 pi. If there's 360 degrees in a circle, there are 2 pi radians in a circle. Because if we have a radius of 1 unit, which deals with a unit circle, okay, then there are 2 pi radians in that circle. So, what does that mean? Well, if the radius is 1, this arc length is about 1 to get to there. This arc length is about 1 to get to there. And then another 1. And then another 1. And then another 1. And then another 1. Okay? 1, 2, 3, 4, 5, 6. And then there's a little left over, which is about 0.28. 6.28 is 3.14 times 2, right? What's 3.14 the same as? Pi. Okay. So 2 pi is like 6.28 radians. So whatever the radius is, okay, you take that times 2 pi to get the number of radians. So let's say the radius of this circle was 2. How many radians to get around the outside? Well, the radius we just kind of swing down to here, and here's a 2, and 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 it looks like we have 0.56 left over. Okay? So that's like 2, 4, 6, 8, 10, 12.56 radians. So basically, the distance of the radius of the circle, if we take that, there's going to be 2 pi times that radius for the number of radians in the circle. Okay? So that's how the radius relates to the radians. Now, what we need to know in trig is this right here. This is the biggie. That there are 2 pi radians in a circle in 360 degrees. What if I divide both sides by 2? 360 divided by 2 is 180. 2 pi divided by 2 is pi. Okay? So in pi radians, there's exactly 180 degrees. So the other day we were dealing with our circle, and we had like a 60-degree angle. If we want to convert that instead of degree measure to radian measure, how many radians is this 60-degree angle? How far is it in radians? Well, we have to do a unit conversion. We start out with what our angle is. And then to get rid of it, we're going to multiply by the number of radians and divide by the number of degrees. You did this in physical science all the time. Your unit conversions. What you're going to goes on top. What you're going from goes on the bottom. Okay? I bet you did this in chemistry too. Or you should have done it in chemistry. So 60 times pi, 60 pi divided by 180 is pi over 3 radians. So 60 degrees equals pi over 3. Let's say you have a 180-degree angle. How many radians is that? Pi radians. Because you take 180 degrees times pi over 180, those cancel and you get pi radians. Okay? Let's say you have 225 degrees. How many radians is that? Okay. Let's do a little math here. Instead of changing this into a decimal, we're going to use our brains to help figure this out. What number goes into both 225 and 180? What's the easiest number? 5 does. So if we divide these both by 5, what do I get? What's 225 divided by 5? 45. What's 180 divided by 5? 36 pi. What number goes into both of those? 9 does. 5 pi over 4 radians. So in 225 degrees, there's 5 pi over 4 radians. How about 490 degrees? Remember, we had coterminal angles yesterday, so we know that you can go up to 490 degrees. You can go up to 11 million degrees if you want to. You just keep going around the circle a whole bunch of times. Okay? So if we take that times pi over 180, what number goes into both of these? The easiest number? 10. So you get 49 pi over 18. Does any number go into both 49 and 18? Because 7 is the only thing that goes into 49. 7 times 7 is 49, right? But does 7 go into 18? No, 2 and 9 go into 18. 3 and 6 go into 18. But none of those go into 49. So we're stuck right there. 49 pi over 18. Okay, so that's converting degrees to radians. How about we make radians into degrees? What if I have 3 pi over 4 radians and I want to go to degrees? What I'm converting to goes on top. What I'm converting from goes on the bottom. So there's 180 degrees in pi radians. Before we multiplied by pi over 180. Now we're going 180 over pi. So I'm kind of hungry when I'm doing this. So I'm going to eat my pies. They're gone. Okay? So what's 3/4 of 180? 3/4 of 180. 135 degrees. So in 3 pi over 4 radians, there's 135 degrees. If I have pi over 12 radians, how many degrees is that? Well, what do we multiply by? 180 over pi. Eat your pies. 180 over 12 is simply 15 degrees. Okay? So, we can convert from degrees to radians and radians to degrees. All right. What's a coterminal angle with 862 degrees? Gotta remember coterminal angles from day one. What do? What? Subtract 360 and you get 502. Subtract 360 again and you get 142. So this is coterminal. So what if we had 19 pi over 4? What's coterminal with that angle? What's coterminal with that angle? Well, what's all the way around the circle? How many degrees? 360. How many radians? 2 pi radians. 360 degrees is 2 pi radians. That's all the way around the circle. So we're going to subtract 2 pi radians. Oh no, we have a fraction. We have a whole number. We cannot subtract fractions with whole numbers. So what we have to do is make this 2 pi into a fraction with a common denominator. What's a common denominator with 4? 4. How many pi over 4 is 2 pi? How many pi over 4 is 2 pi? 8 pi. 8 pi over 4 is the same as 2 pi. So I just wrote this with fractions. Now, what's my coterminal angle? Well, 19 minus 8 is 11 pi over 4. How do I find another coterminal angle? Subtract another 8 pi over 4, and we get 3 pi over 4. Coterminal angles. Okay, let's start out with something easy. 5 pi over 6. Find the next bigger coterminal angle and the next smaller coterminal angle to 5 pi over 6. We want to find one bigger and one smaller. What is going to be our common denominator? 6. So, what over 6 is 2 pi? 12 over 6 is 2, so 12 pi over 6 is 2 pi. If we add that, we get 17 pi over 6. 17 pi over 6 is coterminal with 5 pi over 6. Now I want to find one smaller. How do I find a smaller angle? Well, you take 5 pi over 6 and you subtract 12 pi over 6. So if we subtract 12 pi over 6, 5 minus 12 is negative 7 pi over 6. That's the next smaller coterminal angle. Okay? So that's coterminal angles. Last thing for today. Quadrants. 0 degrees is 0 radians. 90 degrees. If I want to change 90 degrees into radians, I multiply by pi over 180. What do I get? 90 over 180 is 1/2, so it's pi over 2. 180, we said, was pi. What's 270? 270 over 180 is 27 over 18, dividing both by 9. 27 divided by 9 is 3. 18 divided by 9 is 2. So this would be 270 degrees is 3 pi over 2. Okay, so that's where our quadrants are. And obviously this would be 2 pi if you go all the way around. Okay, what if I had pi over 4? What quadrant do you think pi over 4 is? Is pi over 4 bigger or smaller than pi over 2? Smaller. So it's in between 0 and pi over 2 somewhere, right? So it's in quadrant 1. (18 pi over 20). I guess it's 9 pi over 10. Where would that fit in? That's really close to what? Pi. It's really close to 1 pi, right? 18 over 20, because 20 over 20 would be pi. Pi over 2 would be 10 over 20. So it's somewhere in between 10 over 20 and 20 over 20. So that would be quadrant 2. (13 pi over 6). Where would 13 pi over 6 be? Correct, Mr. Wolf. Well, now we got to think coterminal angles here. Because 13 pi over 6 is bigger than 2 pi, right? So we have to subtract 12 pi over 6 from that. Coterminal angles. We get pi over 6. Where would pi over 6 be? Quadrant 1. Okay? So you're dealing with figuring out what quadrant things are at. Now, what if you're stuck? What if you're hit like 7 pi over 6 and you have no gosh darn idea where in the heck 7 pi over 6 is? What can you do? Change it into degrees. How do we change this into degrees? Well, we just take times 180 over pi. We eat our pi's. 6 goes into 180 30 times. So this is 210 degrees. Where would 210 degrees be? Well, right there in quadrant number 3. Okay? So if you get stuck, if you just don't know where that would be radian-wise, just change it into degrees and figure it out from there. Okay? All right. So, radians. Okay? A little different way of thinking. This is a little different trig here going on. So, that's what we had there. Let me stop.